Okay. Oh, and just fair warning, there's a high probability of a quiz on Wednesday. You bringing chili back? Yeah. Because I think class is after 4 p.m. on Wednesday is when break officially starts. So we will be meeting on Wednesday. Okay, so we are creating some getters for our scope-based stack or our scope-based environment that allow us to get individual aspects a little bit easier. And then we are going to update our resolve var, and scope to use these new guys instead of having these crazy CADR and CAADR stuff. All right, so we're going to write each of these guys. All right, so this first guy, get first scope, takes in a scope stack, and this guy should return the first scope. Now, if we look at this, a scope stack looks like this. So what's the first stack in the first scope in a scope stack? The CADR. So that'll give us that first scope. So the cdr gives us the list containing all of our scopes. The car of that gives us the scope itself. So this is define, get first scope, going to be a lambda that takes a scope stack as a parameter and is going to return the CADR of that scope stack. All right, so that's a get first scope. Get the rest of the scope stack should produce for us a scope stack, correct? So it's going to need that first thing, the car of that guy, with the rest of that scope stack. So we're going to define get rest scope stack to be a lambda that takes in a scope stack as a parameter. And we're going to go ahead and, if we want to steal it from what we did down here, should be that guy right there. So cons the car of the scope stack, which is the word scope stack, onto the CDDR of our scope stack, which is the list of all the scopes in the scope stack except for the first one. So that should get us the rest of the scope stack. Now, if we want to update as we go through here, get first scope stack. This guy right here is get first, correct? So we actually want to say get first scope stack on that guy. Passing it the scope stack. This will get us the first scope from the stack. Get first scope from scope stack. Like that. So I'll boil down to the first scope, and then the other guy is get rest scope stack. Ay, ay, ay. So get rest scope stack, giving it the var we're searching for, and call resolve var again. All right, so get first pair from a scope. So remember, a scope looks something like this, where it's going to have the word scope followed by a list of two lists. So the car of the cdr of this guy will give me a list containing this list. The car of the cdr gives me the list itself. The car of the cooter will give me the first to list. And we should use this here in our resolve var in scope. So this guy right here, the car of the cooter will give me the to list, correct? So define get first pair to be a lambda that takes a scope, and this guy is going to return the car of the cooter of that scope. So let's actually go ahead and insert this guy in here. So this is resolve var in scope. So right here, we're trying to get the car of the, that's the to list, right? So that right there should give me the to list, the pair. And then we want to get the variable name of that pair. So define get var name to be a lambda that takes a pair as a parameter, and that guy's going to return the car of the pair. So then we'll take this guy, get var name, put it in there. So this will get the variable name of the first pair and compare it to the var name we're searching for. If it matches, we want to return the value of the first pair. Define get var value to be a lambda that takes in a pair, and this guy should return the car of the cooter of that pair. So we're going to start off, so we're going to get the first pair here. That's that guy. Then we're going to get the var value of that guy, which is that guy. All right. Now, any red flags pop up here? What red flag? What should we probably be using here? A let. Why a let? Yeah, I'm doing the exact same thing 2 different times, so it probably makes the most sense for us to put get first pair inside of a let, so that we only have to do that one time. Now, we kind of know that get first pair is not a super scary type thing, but it would still be good practice to create a local environment to throw that in a variable. If we're thinking of this in Java terms, throw something in a variable so you can use it more than once. So if we're going to do that, we would create a let, and let, we would say pair is equal to get first pair in our scope, something like that. Then this guy would be pair. This guy would be pair. And all this stuff would happen in the body of this let. All right, so now we have a variable called pair. Get the variable name from that pair. If it's equal to it, then we'll get the value associated with that pair. Otherwise, we're going to resolve var in scope. We need the rest of this scope. This returns the scope minus the first two lists. So that's this piece right here. That's rest of scope. So define get rest scope to be a lambda, takes the scope as a parameter, and this guy will return the scope with the first pair removed from it. And we can come down here. And we'll call get rest of scope on that guy. Make sense? Okay. And then have we updated this guy completely? Yep, looks like we have. Make sure everything still works. It does. All right, so if we're going to take this one step further, maybe we would say, let's go ahead and ask if a scope is empty. Something like that. That would allow us to have, because really right now this reads pretty good, doesn't it? And you pretty much know what each section is doing rather than having to look at this car of the cooter of the car of the car of the car of the cooter, blah, blah, blah. Whereas it's pretty easy to just not know what the heck that's doing anymore, right? Now we look at it, we pretty much know what the pieces are. The one exception would be this piece right here. Still abstract. So let's go ahead and give a kind of a parsed version of that. So we're going to have a maybe is empty scope, and this guy will return true if the scope has no more pairs, and false otherwise. So define is empty, and this is probably a predicate, so maybe throw the question mark thing on there just for naming convention. This be a lambda, takes in a scope. We'll go ahead and steal that code there. So we're going to boil down to the null of the catter of that scope. The cooter of the scope is a list containing the list of two lists. The car of that is the list of two lists, list of pairs. And if that list of pairs is null, that means we're out of stuff, and is empty will return true. So now we can ask here if is empty scope, then return false. Otherwise, do the rest of the stuff. Now up here in our scope stack, we also have the ability to find out if are we out of stacks. So maybe what we should do is say is empty scope, just so we can differentiate between scopes and scope stacks, because this is a loosely typed language. Just because I call this guy scope and call the other guy scope stack, Scheme doesn't care. Those are just takes one parameter. Okay, so we'll call this guy is empty scope. So just update that real quick in here. Is empty scope. That way we can write one that's is empty scope stack, which is going to be pretty similar here. And this guy will take in a scope stack, returns true if the scope stack has no more scopes, and false otherwise. Define is empty scope stack to be a lambda, takes in a scope stack, and this guy's going to return this dude right here. And then we'll be able to ask, is empty scope stack on the scope stack? Oh. Okay. Run this again. Okay, we've thoroughly tested at every possible input, so it works perfectly. All right, so do we feel like our code's more readable now? Now, in hindsight, would we have written all this stuff first? All these little tiny things? Didn't we effectively do that last class? We kept doing these little tiny tests, right? Like, how do I get that piece? How do I get the next piece? So realistically, we should have been building these functions along the way, right? But then we wouldn't have had a homework assignment. So it's you were happy you had a homework assignment, right? So there was a nice little easy one over the weekend, bumped the homework grade a little bit. Okay, so this gives us a whole bunch of getters for working with our scope. So now we want to start thinking about, let's go. Oh, hold on. Do we name our language yet? Tears? No, whatever name was mentioned in class was really just not good.
Didn't somebody say like cat, dog, or language or something like that? You said that sounds like
oh yeah. I remember that was at the end, like as we were walking out.
I don't remember who said it though.
Was it Gabe? Yeah, that's not bad. So it's the language cat dog. Where do I even store this? Do I store it in my iCloud documents? Yeah, cat dog. Is there anything else to it? Just cat dog?
Cat, dog, or language.
Oh, cat dog or language. Ugh. So is it going to say cat dog or language like that? I guess that makes sense. Kind of fits. All right, so this is cat dog. So we finally have saved our language. It's really just banking on this thing that not going down. Okay. So now that we have this updated scope thing, we have to go back and we need to now look at our language as a whole and decide what parts of our language now need to be updated. So this is parse. So parse expression is not going to change, but apply expression probably will. Now, realistically, we would probably come in here and write little helper functions for this guy as well. Instead of car parsed expression, we would have get expression name, something like that, and throw it in there in exchange for our parsed expression. That way these read a little bit better. So we come in here, we do define get parsed expression name is a lambda that takes a parsed expression as a parameter, and this guy will return the car of that parsed expression. mean, it does make each line a little bit longer, not the end of the world, but at least we know what we're accomplishing with that. So if we come back 6 months from now and look at this again, we know what we're actually getting from each of these questions. Okay, so we have that guy. So we're asking if we're dealing with a constant expression, then what are we going to do? So again, we have all these little pieces here, like the CADR of parsed expression. So this would be, if it's a constant expression, this would be getting the value of it. This would be getting the value of a Boole expression. Here's our diff expression. Inc expression, dec expression, repeat expression, or expression, and or XOR less than. So those are Booleans. Here's our let expression. Okay, right here is our apply expression. So or a var expression rather. So at this point, the only way that we can get a value out of a variable is through our var expression. And right now what we're doing is we're calling apply env, passing it an environment. Now right now this environment, we're presuming it's our old extend env type of environment, right? So we have to go back and revisit apply env. Probably up here with our environments. All right, so here's our apply env. That's going to take in an environment and a search variable that we're searching for. All right, so what we want to do is we want to create a apply scope stack. And we already kind of have that, right? So we have something called resolve var that takes the scope stack and the variable name we're looking for, and this guy does all the work, right? So instead of calling apply expression, we want to call resolve var, passing it the scope stack. So that means down here in our apply, we need to give ourselves our empty. So initially, we're going to have an empty scope stack. So let's give ourselves a constructor for that. That will be a scope stack that has a scope that has no variables in it. Correct? But actually, we might want it to go ahead and... Why don't we give it these starter variables, just for the sake of testing here. So I'll get rid of those two things. Get rid of this. We're going to move those. I copied those. We're going to move it down to right before we call apply program down here at the bottom. So right now, here's the environment we're passing in there. So we're going to get rid of this environment, or starter environment. And instead, we're going to define a global scope, and this will have two variables in it. An A is 5 and a C is 7. And I'm going to leave our, well, we'll leave that empty. We'll leave that, actually I'm going to leave that scope 2 in there for right now so we can remember the setup for that. And then we're going to come down here, and our scope stack initially is going to be just our global scope. Okay, because when we start our program, we kind of need to give it a starting point. And right now, since we don't have the ability to put new variables into our scope, we don't have a block structure yet. We're going to have to give ourselves a couple of variables if we need to be able to work with those. But we won't do 2 scopes now. We just know we could if we needed to. All right, so I gave myself a global scope. This is just a reminder for us how the second scope will work, but I'm not going to put it inside of our scope stack at this point. Okay. Now, this is just printing out our parsed program, then we're applying that program, and we need to apply that program inside of our environment. All right. Now, we can make the assumption that our environment is a scope stack based environment. Is that a fair enough thing? All right. So that would prevent us from having to go and change env to change it to scope stack. So what we'll do is we're going to pass in our scope stack for our initial env. And then from that point forward, we're going to be passing it as a variable named env. That's the environment in which, and we call them variable environments in Java. We don't necessarily know how it was implemented, whether it was a stack. Well, we kind of do know it's a stack of scopes, but we don't worry about how it was actually implemented as long as we can use it. And then down here, instead of saying apply env, we want to resolve our variable. What variable? The variable name in this environment. So that's going to be this guy we had up here, resolve var. So this is our equivalent to apply env, but for scope stacks. And we now know we're passing a scope stack into our language. All right, so that's down here. So instead of apply env, resolve var in that environment for that dude. Okay, and just for testing purposes right now, let's go ahead and let's just give it a program that's just A. We'll parse that program, which will give me a var expression for A. We're going to print out our parsed program just so we have it. Then we'll call apply program on that program, passing it our scope stack, and in this case, it should give us a 5 because it was able to resolve A in our scope stack. So there's our 5. Make sense? So all that work, we're right back to where we were before. But now, what can we do now that we could not do before? We spent the last 2 classes doing a whole bunch of work, moving over to a new type of environment. What can we do now that we couldn't have done before? The correct answer is not do our next homework assignment. Because I have big plans and you probably won't be able to do it. Go ahead.
Show it to someone who doesn't know what car untitled means and they can read it.
Oh, that's probably a true statement. That's probably a true statement in our language here. I'm talking about for us. We know what car and cooter means. What does our language allow us to do now? We've upgraded our language. Our language is more powerful than it was when we were using an extend env-based environment. Now that we have a scope stack-based environment, we can do more powerful things that we couldn't do before. What was the wall we were bumping up to before? What couldn't we do? What led us down this path? We were looking at like a for loop, right? And one of the issues with a for loop is for loops kind of, if we think about a for loop in Java, they have their own scope, right? We couldn't do that. We couldn't have this separation, this idea of having a more locally defined version of a variable. Effectively before, what we had is just a list of variables that extended each other. So I mean, you could create an A is 5 here, and that might have extended something 9 variables down that was A is 3. But we didn't have this disconnect on, we didn't have the ability to separate individual scopes. Each one of our variables kind of functioned as a scope. We couldn't pass them around as their own little environments. So now we can do that. Now we can say, for as long as this for loop lives, here's its environment. Okay? And here's the more global environment in case we're looking for something we didn't find in the local one. That starts sounding more like Java, doesn't it? We didn't have that ability before. We just had this idea of, here's all the variables I know about. Search. Good luck. Okay? Now, we still have another limitation. When we think about Java, we look at a Java program. Let's flip over here. I have Eclipse, I think, open. All right, so what are the things I'm doing inside of this Java program? We just think about that as our program. Forget about the extra stuff outside of that. I'm defining some variables, right? Now, in our current language, can we define a variable? We can kind of hard code it into our scope to begin with, but we can't at runtime create one. That would certainly be nice. This is something we can add to the language, right? Okay, so now we also can't print stuff, but we sort of can in our language, right? Couldn't we say, in our language, couldn't we say something like, assuming we could define it, int a is 5, and then boil down to a? This would be a var expression. This would be, maybe we call this guy a define expression. So presuming we could define a into our environment, or in our case now, we kind of hard-coded in there, just we have a. We put it in there. So we did define it ahead of time. If we want to print out a, we do this program right here, where it just boils down to a. Make sense? Okay. So we don't have the ability to at runtime define a variable. We have to mention the variable ahead of time. But if we think about what's happening in this program, this is defining, displaying, defining, displaying. These are all just 2 moves, right, that we're doing here. But doesn't this line rely on the changes that were made from this line? What's this guy called, what I have highlighted right there? Or how does that guy work? Forget about what it's called. So I have an opening and closing curly brace there. How does that work? Do all the lines happen at the same time? They're sequential, right? You start at the top and you work your way down. So this line. Now, does this guy right here come with his own scope? We get a new scope with this guy. When we first learned about scopes, we probably made this kind of loose statement that pretty much anytime you see an opening and closing parenthesis, a scope was born. Scope was born. We're going to leave it like that. Okay, a scope was born. That's a mostly truth. Things get a little fuzzy in Java because for loops are kind of weak scopes and while loops are actually even weaker scopes. But regardless, we can think of it as, generically speaking, anytime we have, this is a block structure. An opening curly brace followed by a bunch of stuff followed by a closing curly brace. Things happen sequentially, and that guy comes with a brand new scope. So we get a blank scope, or actually we get a scope that starts with what in this guy? Do I have any variables in my scope initially? My new scope? That guy. So that guy was kind of born with this block structure. Now, it was a bit of a loaded question because we also don't know how to create functions yet. So in actuality, this is a function that is defined in terms of, this is the single statement associated with that function. And the type of statement that is in Java is a block statement. And a block statement is a collection of 0 or more statements. Similarly, with like a for loop, where when I originally teach for loops, I originally teach if statements. I mentioned that the curly braces are not required, but you'll never be wrong to have them there, because technically an if statement is the Boolean expression, if Boolean expression, then statement. And we choose most of the time to use block statements. So we can execute just one thing instead of a block statement, because what's a block statement? A collection of 0 or more statements. So if we associate a block statement with a for loop or a block statement with an if statement, anything like that, we don't need the curly braces if we didn't want to for a for loop to exist. But if we always associate a block statement with a for loop, it's never going to be wrong. In fact, some of our newer language like Swift require if statements and loops to have the block statement associated with it, even if you're only going to put one thing. Just a better way of approaching it. Okay, but the punchline here is that this guy has a scope, and that scope can be expanded by what happens inside of here. Now, as a language developer, you could make the choice. You could decide that you want this scope to actually be different than this scope. Now, if you did that, if you said, I want this scope to be different than this scope, what would that allow us to do? Or maybe I'll ask the more difficult question. Yeah, I think it's the more difficult question. How does Java do it? Is this all one big scope? Or do we have a scope and then another scope inside of that scope? Which way does Java work, and how do you know? Or how could we test it if you don't know off the top of your head? But I'll give you a hint. That's all you should need to know to tell you how Java has implemented this. How many scopes exist in what I have highlighted? One scope or two scopes? Go ahead. One scope, how do you know? Yeah, he's upset that I've defined another variable called args, where it's a duplicate local variable. If these were two separate scopes, so for instance, if I have int a up here, can I say int a is equal to 7 there? Sure, because this is a more global scope than this guy lives in. So I cannot have duplicate variables within the same scope. We don't have that limitation on our scope. Anything you want to throw in there is cool. Right? So we resolve to the not only the most local, but the first one we find in there. So we'll kind of leave it at that for ours right now. But Java does have those kind of checks. So we know that this entire thing is implemented as a single scope because we were just able to test it, that we were not allowed to create a variable named args in here, because there was already an args inside of the current scope. Does that make sense? That would make a good quiz question for Wednesday. I don't know what I'll come up with, but that one wouldn't be bad. Okay. How would a block expression work? Because really, we would like to be able to do something like this in our program. I'll just kind of we would like to be able to create a block expression, however we want to make it. Maybe it's a list of, since we're in a list-based language, maybe we have a list of, let's actually do it in Scheme. So I'd like to be able to do something like define A to be 5. And then I'd like to print out A. And maybe this guy parses into block EXP. And the block EXP is going to have a list in it. And that list is going to have a whole bunch of expressions. This first one is going to be a define EXP A5. And the second one is going to be a var EXP A. Now, as I process this, it should go through a block expression and execute. So it should apply. So maybe initially we have our scope stack that came in here with no variables. Actually, since we have A and C in there, why don't we just call this guy B? And then we'll print out B. So this guy is going to go in, and he should expand upon the environment in which we're currently working, right? And then give us back the answer. So if our scope originally looks like this, and we've, let me just do this real quick. I'm going to print out our scope stack just so you can see what the scope stack looks like. So here's our original scope stack, for example. The very first thing that should happen is we're going to define a new variable B inside of this scope stack. So our scope stack should go from this to that. One more variable that's in it. So that has us, we finished applying expression on this guy, but the result of that apply expression should give us an answer plus a scope. Does that make sense? So the answer of this guy, what's going to get returned, that's our updated scope. That's what's happened as a result of the last last guy. So we're going to get our answer, and maybe that guy comes out as, in this case, since there is no output to that, maybe it gives us a false followed by the scope that resulted from the last expression. Then when I go to execute the next expression in here, this guy, we want this guy to boil down to, in this case, the result, which would be, I'm printing out B, right? And B was 5. The result would be 5. And there was no change in our scope, but we're still going to return the scope like that. Make sense? So right now, for example, when we see a var expression, this guy right here, we are boiling down to resolve var in that current environment with the variable that we're supposed to resolve. So we're just getting an answer. Is there ever a chance that a var expression will modify our scope? That's not what he does, right? Var expression looks up the value of something. So we want to update our apply expression so that this guy returns the list containing that guy and the unchanged environment. That's what he boils down to. The answer and the resulting environment. Because we're going to need both of those pieces to implement our future stuff. That make sense? So I'll leave that as an example. For homework for Wednesday, go through and update apply expression so that each thing returns that to list. The first element is the old answer, the answer we have now. So the first element will be that guy. And the second element will be the resulting environment. Keeping in mind that right now, nothing changes our environment. Make sense? So you are literally going to wrap everything in there just like we have with var expression. Should be very simple, but you're going to get practice working with this. All right? I'll put this up on Slack. This will be due on Wednesday. Remember, Wednesday we will have a quiz. Keep in mind, you are not implementing define and you are not implementing block expression for Wednesday. You're just bringing our apply expression up to the ready for that to be implemented. That way I can give you a really hard assignment over Thanksgiving. I won't give you homework over Thanksgiving. But you better do okay in the quiz. All right, I'll see everybody on Wednesday.